Hello, my name is Gwyneth, and my topic is alternative energy. Within alternative energy, I'll be talking about hydrogen energy and fuel cells. There are many different kinds of alternative energy, which include solar, which uses sun's radiation to produce heat or electricity, wind, which uses turbines to generate electricity from the wind, and hydropower uses dams to create water reservoirs to generate power that utilizes the natural flow of the water. Geothermal is heat that's extracted from the earth to create heat or electrical power. Biomass, which is fuel that's been generated from organic matter or waste from living organisms that's used as energy. Hydrogen energy is an energy carrier that can be used to store, move, and deliver energy that's produced from other sources. And an energy carrier is a substance that contains energy that has to be converted to other forms later on. Types of hydrogen energy include gray, which is produced from coal or natural gas, which releases carbon emissions as a byproduct. And an example of this would be the steam methane reforming. And there's blue, which is just gray energy that has a carbon capture device on it, which either puts it underground or cleans as much as it can. Green energy produces electricity to power an electrolyzer that splits hydrogen from water molecules to create hydrogen and oxygen, and there is no other byproducts, which is an example would be fuel cells. The production of hydrogen comes from a variety of resources like natural gas, nuclear power, biomass, solar power, and wind power. And because hydrogen is an energy carrier, any hydrogen that's within these things needs to be separated from the other elements in the compounds or molecules. And the methods of production, which would be the natural gas reforming, which is the steam methane reforming, which is 95% of all hydrogen production energy. Electrolysis, which would be a fuel cell, which splits water into hydrogen and oxygen that creates electrical power. Combustion, which would be like fuel cell electrical vehicles. There's solar, which uses the solar energy to create powered electrolysis. And then biological processes use microbes to break down organic matter or wastewater to produce hydrogen. There are pros and cons to hydrogen energy. Pros would be there's clean energy through green hydrogen, which is no carbon emissions because it's only oxygen and hydrogen. It is produced from a variety of resources like nuclear power, biomass, solar, wind, natural gas. There is an abundance of hydrogen because it is the most abundant element at 75% of the mass of the universe. It is very versatile. It can be used to power computers, vehicles, like we saw with the fuel cell electrical vehicle, and it also can power, it can heat homes, buildings, light homes, etc. And it does mitigate greenhouse gases through the production of no emissions. So it can reduce our use of fossil fuels, which is also a con because a lot of hydrogen energy that is from fuel cells uses the majority of fossil fuels, which we should lose our dependence from. And another con would be the advanced technology that hydrogen needs. It is highly advanced and very new, so there is a lot of money that needs to be put in, as well as the equipment to store and transport, because hydrogen is a less dense gas than gasoline or diesel, so it needs a special container. But if it is compressed, then it can be up to 3 times the density of gasoline or diesel. It costs a lot to produce and keep up the equipment for fuel cells as well, so that's a drawback. And the infrastructure, we don't have the infrastructure to support because it is so new and so expensive, we don't know if it is worth it to use, as well as there isn't a lot of support and hydrogen facilities that we can use to get enough power for the population that we need it for. Fuel cells, green hydrogen energy, they use chemical energy of fuels, which in this case would be hydrogen, to produce electricity. They do need an input of fuel always to produce the electricity, and they are classified by the kind of electrolyte that they have inside them, which kind of decides what chemical reactions, electrochemical reactions will take place. There are many different methods, but the method I will be talking about, which is the most common and most used, is the PEM fuel cell, which is the polymer electrolyte or proton exchange membrane. And it is a little bit slower, but a lot more efficient than the combustion method. And if we can see here, fuel will be fed into the anode, as well as air will be filled into the cathode. And a catalyst at the anode, which is right here, will break apart the hydrogen to produce the protons, and then electrons, which will go through this electrical current or the load down into the cathode, which will create a flow of electricity. And then the protons will go through the electrolyte here, as we can see, and to the cathode, and then it'll meet and it will produce oxygen with oxygen and produce water and heat. So we can see here, there's the chemical reaction happening. There's hydrogen, it's breaking down into the hydrogen plus, which is the protons, and then the electrons goes through the electrical current, which is the load, and back out, and it's right there. And it will produce heat, very small amounts of heat, and electricity. And hydrogen combustion is usually an engine that burns hydrogen producing power, and the process is air and hydrogen and a pilot fuel, which is a fuel for the purpose of igniting it, will go into the intake valve, and it will compress, like that mixture will compress, and it'll be ignited by the spark plug, which will push down, and then that explosion will drive the pistons up and it will drive power, which will turn your wheels of your car. The process of natural gas reformation produces gray or blue, depending on if you have carbon capture devices. There is a byproduct of carbon, though, so that is not good for the environment because of greenhouse gases and CO2 emissions. It is a thermal process because it does produce heat, but it also intakes heat. And so because this is 95% of all hydrogen production, it's important to note that even though it is supposed to be a clean energy, it is not, because there is the output of carbon monoxide and dioxide. It is inexpensive to get these natural gas fuels, and that is why it thinks it's going to lower greenhouse gas emissions, because it won't use as much and it won't produce as much because it will have trace amounts of CO2, but it still has carbon monoxide. So with the steam methane reformation, you can see the methane will react with steam or like water, and it'll have a nickel oxide catalyst, and it'll have a little bit of heat to create carbon monoxide and hydrogen. And it'll also have trace amounts of CO2, but that would be from the second process, because water gas shift reaction would be them taking the carbon monoxide to produce even more hydrogen later on because of the addition of water. So they'll add more water and another catalyst, which would probably be another nickel oxide, and it'll produce CO2 along with hydrogen, and that will be an exothermic reaction as well, but very slightly, and it'll produce a little bit of heat. So the overview would be that hydrogen energy is mostly clean, although we don't use the clean method mostly, but there is no environmental harm if we do use the fuel cell method with green hydrogen. The future is that there is a lot of growth in the market and research, which should be going into it, which will move us towards a more eco-friendly and cleaner environment and population. Fuel cells, chemical processes to cleanly produce hydrogen energy. And the net zero 2030 is a goal set by Canada to have zero emissions, which can be utilized with hydrogen energy through fuel cells to help meet this goal. Okay,